Okay. This is a very important classwork. Very important. We are going to look at how we can use our knowledge of polynomial division to graph functions that are basically just a transformation of y equals 1 over x. So we're combining two things together today. Let's start off with polynomial division. It's been a little while since you've done it. When I'm dividing, I take what is the divisor and write that out from the highest degree term down to the constant term. And then, actually, that numerator, that is your polynomial dividend. That is the thing being divided. That needs to show up inside the boxes. But you're doing division, not multiplication. So that means that you're going to start by, let me erase this a little bit. You're going to start that numerator polynomial by just writing its highest degree term in the upper left box. Does that bring back some memories? Then you can figure out what needs to go here by thinking about the multiplication. This box will multiply with x to make the 3x. So what is it going to be? Somebody type it in. What is that? And you guys, what is it? You can even hold up fingers. Good. Excellent. Then finish that column's multiplication 3 times -1. Now, you need for this next part to be what you get when you add these two together. So -3 plus what is equal to +8? Somebody type that in. Who hasn't already typed in? Hold up fingers. Yay. Yay, good. 11. +11. Now, if you remember from the division, once you get that constant term in your quotient, everything after that is remainder. So what is this saying? This is saying that 3x plus 8 divided by x minus 1 is 3 plus a remainder that I was not able to divide by x minus 1. And just to let you know, what we're focused on today is actually looking at rational functions where you have a linear function, so like mx plus b kind of thing, over another linear function. If your two polynomials in the numerator and the denominator are both lines, they're both linear, I guarantee you that what you have is a transformation of that y equals 1 over x. So realize that this allows you to graph a whole bunch of different rational functions. And then later we're going to go to higher degree issues, but right now I'm just sticking to linear over linear. All of them can be written as 1 over x with some sort of transformation. So, in yesterday's homework, if you had seen this and you were asked to graph it, what I've been focused on telling you is, first, parent graph. Parent graph is y equals 1 over x. You want to start by graphing the parent graph. After you do that, look at what is involved in multiplication division. So let's take a look at this equation here. Do you see any multiplication or division? And if it helps, take out addition, subtraction. That's one thing you can do. Do you see addition, subtraction? I'm going to highlight the addition and subtraction and what's left. What's not highlighted in blue? 11 over x. If you take out the addition, subtraction, you will see what the multiplication is. And that is the second step. Step 1, parent graph. Step 2, multiplication division. And then lastly, in step 3, if I am adding to the function itself, I am moving it vertically with the operation I see. I see a positive 3 being added. So that means that this graph will be moved up 3 units. And then stay awake, stay with me, I know. Then take a look at this. If the addition or subtraction is with the x, then it's moving it horizontally, but opposite what you would think. Which way are we moving it due to that minus 1? Are we awake? Okay, which way are we moving? Right one. So this is giving us a step-by-step guide of how we're going to go through graphing it. So I'm going to start with the parent graph. And you are expected to remember that the parent graph goes through 1, 1 and negative 1, negative 1. It has asymptotes. The x-axis and the y-axis themselves are asymptotes, and if you draw dashed lines, that helps you to guide the graphing. Now you should be familiar with the fact that the graph goes la-da-da-da, la-da-da-dee. You don't have to be perfect in your drawing, but I'm going to erase what I'm drawing right now in just a moment. So this is your parent graph, but you don't have to draw this. What you do want to do is plot the points and draw the asymptotes. So I'm going to back up and just the plotted points. Now, the multiplication division, we have a multiplication by 11, and do you see that you could actually write this as 11 times 1 over x? So what you see as a number showing up in this numerator, that is what you're going to multiply the y coordinates by. So if I go back to the parent graph and just the single 2 points that I have y-coordinate 1 for this point. I'm going to multiply that by 11. Keep the x that I have. And then for this one, I have y-coordinate -1. I'm going to multiply that by 11. And what I'm going to do next is I'm going to draw these graphs, but I'm going to erase it again. This stretching is going to, yeah, I'm doing a so-so job at this. I'm not going to expect you to draw me the perfect graphs. But realize that we have symmetry going on. So do you see how I have multiplied by 11? Okay. Yep. Yes. 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 Every time you do the multiplication, those asymptotes cannot possibly change because of the fact that they're sitting at 0 values. So if they're sitting at 0 values, multiplying those 0 values by any number, they're still 0 values. And that's really important to be aware of. And it especially helps to realize that this motion actually tells you where those asymptotes end up. Because the only way those asymptotes move is through that actual translation of left, right, or up, down. Now, if you want to draw more accurate graphs, let me tell you that you have symmetry points. 111. If you look at this, when x equals 1, y is equal to 11. But when x is 11, y is equal to 1. If you want to be more accurate, that can allow you for more accuracy. When it comes to my grading of a test, you need to know the minimum. The minimum requirement is that you take these 2 points and follow them through the morphs. If you can do more accuracy, that's fantastic, but I'm not going to grade you down if you're not able to be more accurate than that. So that can help you a little bit with graphing. Okay, now the last step is to move everything. So I'm going to highlight the points that I expect you to follow, and those points are going to be moved. I'm going to move them up 3, right 1. So up 3, right 1. Up 3, right 1. And if you really like to keep your accuracy really pretty, shall we say, take this other symmetric point and do the same thing of up 3, right 1. Up 3, right 1. Most importantly, though, those asymptotes. I'm going to erase the asymptotes as they are. And as I show you how to do this, you need to be thinking about how much work you need to go through to properly get these graphs. You may not need to draw these asymptotes until you're at the end of the graphing, and that's fine. So you can literally read this, and this tells you where your asymptotes are. Up 3. Up 3 means y equals 3. Right 1 literally means right 1. And now I'm going to take the multiplied parent graphs, and they are just moving. But if I understand how they interact in those asymptotes, I can actually just erase them. I'm trying to erase just the asymptotes. Okay. Or not the asymptotes, the graph. And now remember, those highlighted points that I have there had been moved. And I'm going to draw the final graph in red. I need to see that you're going through this point. And then just draw within the asymptotes. The asymptotes are meant to be guides. Make sure that you follow this point. And then that is it. Now, I took a long time to go through very small steps. Some of you are going to be able to very quickly get through these steps once you see what it is that you're doing. But I'm going to take you slowly throughout this classwork. Hopefully by the time we get to the last problem, you might actually be able to do it pretty quickly. So, are we ready? We're going to go again. Problem number 2. Brand new problem. I'm going to erase this out of the way so I don't see it. Is everyone ready? Are you excited? Where's that excitement? I know, I'm trying really hard. Hey, woo! So here we go. Polynomial division. I'm dividing by x plus 2. I need to get 4x minus 1 inside the boxes. So I start with the leading term, 4x, in the upper left box. That forces what this has to be, because it has to multiply to x to make 4x. Then that forces the rest of this column. 4 times 2 gives me 8. And then, in order to get 4x minus 1 inside the boxes, I have to figure out what do I add to 8 to make negative 1. And you're all thinking about it and going, oh, I know. What is it? Is that what you're getting? Negative 9? All right. And because this quotient is just a constant, that means everything that occurred after that is part of the remainder. So what does that tell me? That tells me that the answer to my division is an entire quotient of 4. And then plus a remainder of negative 9 that did not get divided by the x plus 2. Okay, so hopefully you're feeling good with that division. The next step is to graph. So you want to start with, oh dear, we're hearing band practice, I think.
Yeah, it was going on yesterday too.
Yeah. So start with the parent graph points 1, 1, negative 1, negative 1. Keep in mind that the x and the y-axis are asymptotes. My recommendation is highlight things being added or subtracted. I've got a +4 and I've got a +2. Write down what's left over. This tells you your multiplication. And realize that that is the same thing as 1 over x being multiplied by -9. So that means that the y value 1 needs to be multiplied by -9. That's going to force the graph to flip over the x-axis and stretch. Then take the y value of -1, multiply that y value by -9. -1 times -9 will give you +9. So that does the flip and the stretch. And I call the flip, I don't know if you call it reflection, you can call it whatever you want. But I just kind of want to emphasize what the multiplication does. Now, these, I'm going to erase my initial points. These 2 points you must have and you must do the translating from. If you want more accuracy, be aware that these graphs are very, very symmetric. So this point that is 1, -9 has a partner point over here. Do you see what I mean by the symmetry? Because inside these 2 asymptotes, you have one graph, and that one graph is actually symmetric inside of those 2. And if I could draw it a little bit better, perhaps you could see what I mean. But is that maybe good enough that you see what I mean by that symmetry? Maybe that's a little bit better. And then basically it tries to head toward the 2 asymptotes in the same manner on both ends. And then over here, I have this point that is -1, 9. It's going to have a symmetry partner within its view of the 2 asymptotes. Yes?
So for the homework, are we going to have to graph 6 separate lines onto the...
No. On the homework, you can go as quickly as possible to the final graph. What I would recommend is maybe you can use a pencil and erase things as you go along, or you can print out more of these graphs to have more like slow processing. But once you get the hang of these, you may not need the processing as much. And you can go straight to the answer. And The asymptotes really only need to be drawn after you realize the shifting that happens. So I want to say again that the highlighted points are the only ones I'm expecting you to follow. But if you want more accuracy, drawing that symmetric partner within each quadrant really helps. Now, do you see what the addition / subtraction is telling us? This plus 4 is saying we're going to move it how? Up 4 units. This plus 2 is telling us we're going to move it Is everyone still with me? What's that plus 2 going to tell me to move? Good. Excellent. Yes, left 2. So I expect you to take these 2 points and do that movement. If you want more accuracy, you can work with the other pair of points, but grading-wise, I'm not going to push it. So up 4, left 2. Up 4, doot, 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 left 2, boop, boop. And then up 4, doot, 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 left 2, boop, boop. Do you like the sound effects? I don't know if it's annoying, but hey. If I want, I can also take these other symmetric points, up 4, doot, 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 left 2, doot, doot, up 4, doot, 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 left 2, doot, doot. And then the asymptotes are up 4 and left 2. So what I'm going to now do is I'm going to erase the graphs and their asymptotes. I'm going to erase the original points and just leave these points that I found. And now I'm going to draw the asymptote of up 4 and left 2. And if you at least have these 2 points and you understand that what you're getting is 2 curves in opposite corners that stay inside of those 2 asymptotes, then you can go stay inside the asymptote, whee, stay inside the asymptote, whee. And again, those extra points kind of help a little bit. You're not going to draw perfect, just draw good enough. And when the test comes around, this could turn into a multiple choice type of thing. But while you're doing your homework, I want you to draw the graphs and experience going through this process. All right, now you might be getting the hang of it. In your homework, just to let you know, in your homework, you are going to do this 1, 2, 3 times. And you should be getting to hopefully a point where you feel a little bit comfortable with that process. What I'm going to do next, though, is introduce you a little bit to when the polynomials are higher degree. How much can you know, and how much are you kind of left with, I don't know. So Here we go. I'm going to do polynomial division. So I've got x plus 2. And then I'm going to take my highest degree term, put it inside the box, and then get going. So x times x gives me x squared, multiplying the 2 and the x. Then I need that box to add with this box to make 5x. And then you go, I know what that's going to be, right? 3x. Now, right now my quotient is an x to the 1 power. I keep going. X times what is 3x? A 3. Multiply the 3 and the 2 to get 6. And then these two have to add to make positive 6. And you go, oh, but it already is. What? Now, also, when my quotient hits that constant, anything that goes after that is a remainder. I don't have a remainder. That means that I literally divide these and get a polynomial. Can you graph that polynomial? X plus 3. You're graphing y equals x plus 3. Y-intercept is 3, slope is 1. And I'm trying to do my best job at drawing a slope of 1. No, not perfect. Yeah. However, there's an issue. Negative 2 makes a divided by 0. That means x is not allowed to be negative 2. So what I'm going to do is I'm going to go look for x equals negative 2. And I'm going to look at where that point was going to show up. And I'm going to draw an open circle there. I'm going to show you what the answer looks like. Now, understand that this is just an issue of, this is telling us that one point doesn't exist. How big is that point? Technically, it takes up no size. But by you putting an open circle right there is expressing to the person reading that graph that one of the points doesn't actually exist. But other than that, you've got a graph of a line. So know that if you're able to completely divide the polynomials with no remainder, you are going to graph a polynomial. Just whatever makes that denominator 0 has to be specifically plotted and an open circle placed there instead. Now, I want to warn you before we start number 4 that this is going to be something that I'm not going to expect you to be able to graph on your own. But I'm going to kind of talk you through what you see. So here we go, polynomial division. And some of you are good at watching time. How much time do we have left in class? What?
20 minutes.
Thank you. I got 20 minutes, so that's good. We got enough time for the quiz. Okay, I'm going to divide by x minus 1. I'm going to first make sure that I have 2x cubed, the largest degree term, inside my upper left corner. Then x must multiply to a 2x squared to get me that 2x cubed. finish the multiplication, I have to have this being a negative 2x squared. Then when I add these two boxes together, I should get my x squared term. That means I need to add an additional negative 5x squared. Then, next step. What do I multiply x by to get negative 5x squared? And then finish the multiplication, negative 5x times negative 1. And then I am supposed to be able to get from the addition of those two boxes my x term. But wait a minute, there is no x term, is there? So maybe you remember that that means I have a plus 0x. So what do I need to add so that I have a plus 0x? Then I'm ready to continue. What does x multiply by to make negative 5x? And notice I just hit a constant term. So that means anything that occurs past this line is remainder. Negative 5 times negative 1. And then I need those two to add up to make positive 6. And that's going to be the number 1. Now that means that I get out of this an entire polynomial of 2x squared minus 5x minus 5 plus a remainder of 1 that I was not able to divide by that x minus 1. Now, what I want you to do is get out a graphing device. It could be Desmos. And I want you to graph this function. So I need to remember what I am graphing. Give me a second. Okay, so let's type that in. Y equals 2x squared. I'm going to put the squared in a minute. Because I need to stop looking at my problem to open this up. Oh. I'm not going to comment on that. Now, how weird is this graph? Were you expecting that at all? No. So I'm going to change, let me see. I want you to notice something. What made the denominator 0? What value of x makes the denominator 0 in that original division? X equals 1. I want you to look at the graph and see what's happening when x is 1. What's happening? Anyone want to tell me the name of what this is? What is that? It's an asymptote. So here's the thing. If you do the division, whatever is making that denominator 0, it is either going to create a vertical asymptote or it is going to create a point missing from the domain of what would have otherwise been a smooth graph. That's always what's going to happen with your denominator polynomial, and that's really important to grab a hold of. The denominator polynomial, anything that makes that denominator 0, is either going to be a vertical asymptote, or it is going to be a place in the graph where it was going to be smooth, but it ended up being a plucked out point. And let me also show you something else about the one where it divided perfectly. If I decided I wanted to factor this numerator, do you see what it actually factors to? I need two numbers that multiply to make positive 6, add to make positive 5. What are those two numbers? Multiplies to make 6, adds to make 5. Plus 3 plus 2. Oh my goodness. What? Look at that, look. Ah! If you do division and you don't have a remainder, you are dealing with a factor that can actually cancel with that denominator. And so you can see through that just nicely getting the line. So I wanted to point that out to you. You can't, this one, you're not going to be able to factor x minus 1 from that numerator polynomial. Now I'm going back over to here, and I'm going to do something, and maybe you'll find this interesting. Yes. Are you sure we have 10 minutes left? Oh, 1 more minute. I have an alarm that goes off. So hold on 1 second. And I am going to change something. Are you ready? Are you ready? This might. Okay, it's taken some time. Whoa. Go back to home. I want you to see that when you do that polynomial division, the full polynomial you get out, the graph is actually trying to become that on the far ends. And let me do this so you can see it better. Can you kind of see that? That's interesting to take note of. Now, I'm not going to be making you go through actual graphing of problems like this one. But what I want you to definitely get from that is the idea of if the denominator is equal to 0 for a certain x, it will create a vertical asymptote unless it is able to actually cancel with a factor in the numerator. Or in other words, if I did division by that x plus 2 or whatever factor is there, I would get no remainder. Otherwise, it's a vertical asymptote if it makes the denominator 0, and that's important to take note of. Now I'm going to stop recording.